Uniform circular motion. A particle is a uniform circular motion if it travels around a circle or circular arcs at constant speed. And that is what's happening in uniform circular motion. Look at this one. Okay, it's looking around. Okay, the velocity direction of the particle in the uniform circular motion changes all the time, but it must along the tangent to the circle or circular arc. Although the speed does not vary, the particle is accelerating. That factor may be surprising because we usually think of acceleration as an increase or decrease in speed. But actually v is a vector, not a scalar. Okay. If v changes even only in direction, there is an acceleration. And that is what's happening in uniform circular motion. You see, the velocity changes direction, and it does have an acceleration called centripetal acceleration toward the center of the circle. Now, let's prove it. First, let's see the situation. This is the point. This is a vector v along the tangent perpendicular to r. It's a location. This is x-axis, y. So its position is xp, yp. This is r. This theta, and this is theta. Why did that? This line perpendicular this line. This line perpendicular this line. So they are the same. Okay? Now let's see Vx. Vx here is minus V sine theta. Right? Direction is minus. And what is sine theta? Look at this triangle. Sine theta equal to yp over r. Okay. Next, Vy. Vy is V cosine theta. And cosine theta in this triangle, this is xp over r. Okay, this is V. Now, let's see, let's look at A. A is dv dt. So Ax is dvx dt. We put this one here is minus Vyp was inside. And we will see that this V, velocity, speed is constant. R is constant. So we take this out. The leftover is dyp dt. What is this? This is Vy, Vxy, right? And then Vxy. Okay. What is Vxy? Further, Vxy you could V cosine theta. So put the V cosine theta, we get a V square over R cosine theta minus. Next, we see the Ay. Ay equal to dvy dt. dvy equal to this one, Vxp over R. And as V is constant, R is constant, we take it out. Inside becomes dxp dt. This is a Vx definition. And Vx equal to minus V sine theta. Okay? We put the d minus V sine theta, get a minus V square of R sine theta. Now, we have Ax minus V square over R cosine theta, Ay minus V square over R sine theta. We put this one, we can find the A. A is Ax, A square equal to Ax square plus Ay square. We put this one inside. This is blue one is Ax. Okay. And the red one is Ay. We take the V square over R square out. We get a cosine square theta plus sine theta square. That's equal to 1, whatever theta is. So we get A equal to V square over R. This is the magnitude of acceleration. This is centripetal acceleration. We are familiar with in one-dimensional, right? Yeah. Now I prove it. How about direction? Our direction, this is phi. tangent phi equal to ay over ax. This is ay. This is ax. So we cancel out v squared over r. We get sine theta over cosine theta is tangent theta. What does mean? Tangent phi equal to tangent theta. Tangent theta below is just from center to this theta. So what this mean? This means this A is toward the center of the circle. It's directed along the radius and toward the circle center, the centripetal. Okay? Example. Top Gun pilots have long worried about taking the turn too tightly. As a pilot's body undergoes centripetal acceleration with the head towards the center of the curvature, the blood pressure in the brain decreases, leading to loss of brain function. There are several warning signs to signal a pilot to ease up. When the centripetal acceleration is 2g or 3g, the pilot feels heavy. At about 4g, the pilot's vision switches to black and white and narrowing down to tunnel vision. If the acceleration is sustained or increased, vision ceases, and soon after, the pilot is unconscious, a condition known as G-LOC for G-induced loss of consciousness. What is the centripetal acceleration in G unit of a pilot flying an F-35 at speed V, 2,500 km per hour, that is 694 meters per second, through a circular arc with radius of curvature R 5.80 kilometer. Pretty dark. Then we put this formula, A equal to V squared over R. We know V, we should 9 to 4. And we know R, we should 5,800. We get 33.0 meter, about 8.5 G. It's pretty dangerous to G-LOC.